Welcome back. Today we're going to be talking about dividing integers. Our content objective is students will be able to determine the rules for dividing integers. Language objective is students will be able to write division problems as related multiplication problems. Why am I learning this? Well, it's important for many real-world problems like finding the height of the earth tide given the height of the ocean tide. So some background knowledge just to remember the different ways multiplication can be expressed, what it means. In this case, we know it to be 4 groups of -2. We just write it out, or we can write it as a repeated addition. We even talked about opposite multiplication, which was very effective as well, which some of you might be using. We also showed it on a number line. So here we're going 4 groups of -2, so 1, 2, 3, 4, which leaves us at -8. We need to know that the commutative property states that we can write these instead as -2 times 4, because commutative property allows us to rearrange numbers around the operation. Note it only works for multiplication and addition. So here we can read this as the opposite of 2 times 4. Okay, so the opposite of 8 is -8. Same thing here. The opposite of 2 times 4 is 8, so the opposite of that is -8. So this is using opposite multiplication to get our product of two integers. And again, please note that we're using the commutative property to get to our answer in that way. Okay, so what if both numbers are negative? How could we think of this as? Again, using opposite multiplication, we could think of this as the opposite of 7 groups of -8. 7 groups of -8 is -56. Taking the opposite of -56 is 56. So now it can be expressed any of these ways. They all mean the same thing. Just note when you have a negative on the outside, we're going to read it as the opposite of. If it's avoidable, you can use commutative property and switch the negative to the second number, because then you can just say 7 groups of -8. But if you can't, just read it as the opposite of. Okay, and we also recognized some patterns as we were multiplying positives and negative numbers. We found that when we multiplied a positive times positive, of course it's positive. A negative times a negative is positive. A negative times a positive is a negative, and a positive times a negative is a negative. So the pattern was this. Anytime you're multiplying a positive by a positive, of course it's positive. Anytime you're multiplying a positive times a negative, it's a negative. Why? Because you're repeating a certain amount, you're repeating a group of negative numbers a certain amount of times, so that's why it's negative. A negative times a positive is the same as a positive times a negative, just reverse, so that's the same thing. And of course, a negative times a negative, you think of this as the opposite of X amount of groups of negatives. So your answer would be negative, but then you take the opposite of it, which would give you a positive. So generally speaking, no positive times positive is a negative. A positive times a negative is a negative, negative times positive is a negative, and negative times a negative is a positive. In previous grades, one of the ways that you thought about division was reverse multiplication. So doing 6 times 2 equals 12 could also be thought of as 12 divided by 6 is 2, or 12 divided by 2 is 6. Both of these are the same thing. Okay, so you're reversing it. It's technically the inverse operation of multiplication. It's division. So here, -5 times 4 is -20. Okay, and again, if you want to, you could think of this as a commutative property. You can switch it so that your negative is on as the next second number. So 4 times -5, you can think of this as 4 groups of -5. If you have 4 groups of -5, you have -20. So now, how can I write this as a division? There's 2 ways. You can write it as, hey, -20 divided by 4 equals -5. Or you can do -20 divided by -5 is a +4. So again, we can relate these division problems from multiplication. So let's go ahead and take a look at some of the problems here and try to relate all of these division problems to multiplication. So here, 3 times what gives me 12? It is a 4. So here, what times, you can think of it as what times 3 gives me 12? It's going to be 4, because, and we know 12 divided by 3 is 4. So let's try this again. What times 6 equals 42? 7. Okay, so here, that means 42 divided by 6, which is going backwards, 42 divided by 6 must be 7. So here, negative 9 times what gives me negative 72? Well, I want it to be negative, so I'm going to have to make this a positive 8. And the same way, you can think of this as, hey, a negative 72 divided by a negative 9. Well, a negative divided by a negative, that's going to be positive. And let me check. Does 8 times negative 9 equal negative 72? The answer is yes. Now here, negative 7 times what gives me a positive 56? In order to make this positive, I have to multiply by a negative, and it would be negative 8. So here, to go backwards, you can say 56 divided by negative 7 must be negative 8. And I know this because negative 8 times negative 7 is 56. So here, what times negative 3 is 9? Well, I would say I need to make a positive, so this needs to be negative, and it would have to be 3. Now let's do a division problem. I can write it as 9 divided by a negative 3. If 9 is divided by negative 3, my answer is going to be negative 3, because negative 3 times negative 3 gives you 9. How about number 6? Here, what times 4 is negative 48? Well, it has to be negative, so I'm going to put negative 12 times 4 is negative 48. A related division problem might be negative 48 divided by 4 is negative 12. Or you could have said negative 48 divided by negative 12 is then 4. Okay, so let's look at this. Negative 36 divided by 6. What times 6 is negative 36? It's got to be a negative 6. Let's check. Negative 6 times 6 is negative 36. Looks good. So real quick, let's change this to a multiplication problem. We can think of it as 6 times negative 6 gives you negative 36. Now here, 88 divided by negative 8 is what? Well, what times a negative gives you positive? I'm going to have to use a negative. So what times negative 8 would be 88? Well, it should be 11. Let's check. Negative 11 times negative 8, is that 88? Yes. So as a multiplication problem, I could have written negative 8 times negative 11 is 88. So remember, it's important for you to also understand that division is the inverse operation of multiplication. So if you're unsure, you can always work your way backwards to get to what your answer is from the division problem. Okay, so now here it says create a related multiplication problem for each quotient. Okay, so here, let's see, what could we do to multiply by negative 3 to give me 12? Well, we have a negative. The only way to make it a positive is to multiply by a negative, so I'm going to say the answer is negative 4. So to create a related multiplication problem, I would say, just to prove it, negative 3 times negative 4 gives me 12, but the quotient is negative 4. Same here. Let's see. Negative 8 divided by negative 2 is what? What times negative 2 gives me negative 8? Well, I want it to remain negative, so I'm going to multiply by a 4. But let me prove it. Negative 2 times 4 does give me negative 8. So I'm positive my quotient is 4. So now at this point, go ahead and pause the video and try numbers 11 and 12 by yourself. Okay, so let's see how well we did. Okay, so here, what times 10 gives you a negative 4? Well, that would be a negative 4. So negative 4 times 10 equals negative 40, so the answer is negative 4. For number 12, what times negative 12 gives me a negative 96? The only number times negative 12 that gives me negative 96 would be an 8. So here, to prove it, 8 times negative 12 is negative 96. So the answer is 8. So notice you can do division of integers by relating it back to a multiplication problem. Okay, so yesterday I asked you if you recognize any pattern when multiplying integers. Well, today, do you recognize any patterns in dividing integers? Okay, so let's just practice a little more just in case you haven't. So here, what times negative 7 is negative 84? Well, to keep this a negative, I would have to multiply by a positive, and that would take a positive 12. So I'm going to go ahead and say 12, and I know this because a negative 7 times 12 does give me a negative 84. Now here, notice it's a fraction, but you can think of this as division. You can think of this as negative 18 divided by 3. So what times 3 gives me negative 18? Well, 6 times 3 would give me 18, but if I want to make it negative, I should probably make it a negative 6, because negative 6 times 3 does give you negative 18. For number 15 here, what times negative 12 gives you 108? Well, to make this a positive, I'm going to have to multiply by a negative. What times 12 gives me 108? Well, it's going to be negative 9. And let me prove it to you, because a negative 12 times a negative 9 does indeed give me 108. Now, last but not least, please remember again that a fraction can be thought of as division. So here, what times negative 3 gives a negative 45? I'm going to have to go with, let's see, 15. It should be negative or positive. Well, let's check. Positive 15 times a negative 3 is going to give me negative 45. So I'm going to go ahead and stick with the positive number. I can further prove it by saying, hey, negative 3 times 15 does give me a negative 45. So the quotient of negative 84 and negative 7 is 12. The quotient of negative 18 and 3 is negative 6. The quotient of 108 and negative 12 is negative 9. And the quotient of negative 45 and negative 3 is 15. So now at this point, what I'd like you to do is go ahead and pause the video and try number 17 through 22 all by yourself. Okay, so here I'm just going to go ahead and quickly review the answers with you. Number 17 should be negative 4, because negative 4 times negative 2 does give me 8. Number 18 is 2, because 2 times negative 5 is negative 10. Number 19 is negative 8, because negative 8 times 3 is a negative 24. Number 20 is negative 3, because negative 3 times 6 is negative 18. Number 21 is 9, because 9 times negative 8 is negative 72. And number 22 is negative 5, because negative 5 times negative 3 is 15. Okay, so now let's mix up all these operations and let's see how well you did. Go ahead and pause the video to try numbers 23 all the way to 26 by yourself. Okay, so let's take a look. For number 23, we have negative 16 plus negative 4. Well, here we're just going to compare. I notice I do have more negatives. How many negatives do I have? I have 16 here and 4 here, so altogether I have 20 negatives. How many positives do I have? I have none. So how many more negatives are there than positives? I would say 20. So the sum of those two numbers is negative 20. Number 24, it's negative 16 minus negative 4. Guess what? With subtraction, we're going to have to turn it into addition. So we're going to change this to add. The opposite of negative 4 is positive 4. So here, are there more negatives or are there more positives? Definitely going to say there's more negatives. There are 16 negatives. And whoops, let's just write 16. 16 negatives, and there are 4 positives. So how many more negatives are there than positives? I would say 8. So I'm going to say the difference between these two numbers is negative 8. Here, if you recall from the previous lesson, we did note that, hey, a negative times a negative is a positive. Or if you're not comfortable with that yet, we can think of this as the opposite of 16 groups of negative 4. If we have 16 groups of negative 4, that's going to give us negative 64, but we take the opposite of that, which is going to give us a positive 64. So the product of negative 16 and negative 4 is 64. Now last but not least, here, what times negative 4 is going to give me a negative 16? Well, my answer is going to have to be positive, and it would have to be a 4. How do I know this? Because a negative 4 times 4 would give me negative 16. So now it's important that you keep straight what is what. You know, we definitely compare when we're looking at addition and subtraction. And then for 25 and 26, we could think of it as groups for multiplication and a multiplication related problem with division. But one thing I do want to stress is make sure we still remember with adding integers, we are simply comparing negatives to positives. And remember, whenever we see subtraction, we do want to change it into an addition problem by simply adding the opposite. So here's the multiplying and dividing integer rules. Whenever the signs are the same, they will be positive. But if the signs are different, whether it's multiplication or division, if the signs are different, they will be negative. It is so important that you do not confuse this with adding and subtracting. A lot of students tend to do that. They get some of these, what they consider rules, all mixed up in their heads. But relate it back to what is adding, what is subtracting, what is multiplying, what is division. Go back to your basics and don't try to just remember rules for different types of operations. Okay, so here it says select all that are equivalent to negative 35 over 7. So, which one are all of these the same as? Well, here, this is a negative fraction, so I'm going to go ahead and pick all fractions that are negative that are still follow 35 sevenths. So here, I can think of it as a negative divided by a positive is negative, so this is equivalent. Here, a positive divided by a negative number is negative, so this is equivalent as well. Here, this is a lot. First of all, let's just go ahead and take care of these. A negative divided by a negative is a positive, so this basically turns into the opposite of 35 over 7. Is this the same thing here? Yes, I would agree with C. Here, a negative divided by a negative is a positive, so this is basically 35 sevenths, so this one's not equivalent. And here, you could think of it as the opposite of a negative fraction. The opposite of a negative fraction is a positive fraction. It's equal sign, not negative. So this is not equivalent either. The only ones that are equivalent are A, B, and C. So now let's move on to some word problems. It says here, write a division expression for each situation. Answer the question in a complete sentence. Jasmine borrowed a total of $48 by borrowing the same amount of money from 6 different friends. How much money does Jasmine owe each friend? So here we're starting with $48 and we are dividing it between 6 different friends. Okay, but note there's something important that I missed. Notice she is borrowing $48. Because she's borrowing, I'm going to go ahead and represent this as a negative 48. Okay, so here, what is the answer? What times 6 gives me negative 48? I would say negative 7. So notice because this number is negative, it's kind of reminding me that Jasmine owes each friend. So I would say Jasmine owes $7. Now some of you might be thinking, let's complete this in $7 to each friend. So again, like I was saying, some of you may be a little confused. You're probably thinking, wait, I don't get it. My answer was negative, but how come I wrote it in my sentence it was positive? Because we're using this negative sign to indicate that it's money that she owes because she borrowed it. Okay, now a positive number might have indicated that she either has money. Okay, number 29. Why don't you go ahead and pause this video and try 29 by yourself. So for number 29, it says, Joseph borrowed $6 a day until he borrowed a total of $72. For how many days did he borrow money? So here, again, because it says he borrowed $6, that's going to indicate that it's probably a negative 6. But notice here, he borrowed to a total of $72. So I'm actually going to do 72 divided by a -6 because that's how much he borrowed each day. So I'm just going to go ahead and solve by saying what number times -6 gives me 72? Well, it's going to be a negative number. And to be exact, it's going to be 12. But when I answer this question, how should I phrase it? Should I say that he borrowed -$12? Nope, that doesn't make any sense. So again, this negative just is indicating to us that it is borrowed money. So I'm going to go ahead and say that Joseph borrowed $12. So that actually concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.